What is ozone layer?
In Earth's atmosphere, there is a layer in stratosphere. It is called ozone layer. It is about 15 kilometers above the Earth's surface. This is umbrella of the Earth. It protects our Earth from ultraviolet rays.
Why does ozone depletion happen? Natural process or anthropogenic impact? Here explains anthropogenic impact towards ozone depletion and further to ozone hole.
Understandably alarmed then in the 1980s when scientists noticed that man-made chemicals in the atmosphere.
It was shortly after that that the first pictures of the Antarctic ozone hole came out from the satellite data. Remember that a ground station just looks up and sees one spot on the Earth. But the satellite gives you a global picture of total ozone, and that's where the name ozone hole comes from. It looked like a hole had been punched through the ozone layer.
In retrospect, that was a really good thing to call it, because an ozone hole must be bad. Almost automatically, it meant that people wanted something doing about it. The hole had to be filled in.
Ozone has a natural regulation process, but something was throwing it off balance. Our use of certain chemicals, most notably chlorofluorocarbons and halons.
Chlorofluorocarbon is a very non-reactive gas. You can breathe it, and it doesn't affect you at all. But when you release this gas, it gets fairly well mixed in the lower atmosphere, and then it leaks into the stratosphere. And these chlorofluorocarbons get above the ozone layer, actually. So they get broken down by that intense solar radiation that's sort of beyond the ozone layer. Now, once they do that, they free a chlorine atom. And the chlorine atom engages in a little catalytic reaction. It will react with ozone, and then it will react with another oxygen atom to regenerate itself back to chlorine. So one chlorine molecule in a little cycle can destroy thousands of ozone molecules.
If ozone-depleting chemicals were being released all around the world, why was there so much chemical destruction of ozone happening over Antarctica?
The following is an example of a natural ozone depletion process in stratosphere. This happens due to meteorological process.
Winter, the stratosphere in the polar region is very cold, and so temperature can reach about minus 80 degrees. And in these conditions, clouds are formed. They are called the polar stratospheric clouds. And on the surface of these clouds, there are chemical reactions that convert chlorine compounds to very efficient compounds.
The air cools. As it cools, it sinks. And as it sinks, it begins to spin. And this sets up what's called the polar vortex, stopping exchange with the outside and turning the center of Antarctica into a giant cooking pot, where all the chemistry takes place that destroys the ozone.
The chemistry that makes ozone in such a way that the ozone would be eliminated.
A burst destroyed our ozone layer. There would be nothing to protect us from invisible ultraviolet light from the sun. Ultraviolet, or UV light, is best known for causing sunburns, but it affects all aspects of the natural world.
Layer disappeared. What would happen to life on Earth if there was a big increase in the UV coming on from the sun? That's the question that we're trying to answer. These waters, like all waters on Earth, are full of microscopic plants. They're called phytoplankton, and they provide food for the rest of the marine food chain. They are the main source of photosynthesis in Earth's waters.
Ultraviolet light may disrupt photosynthesis within phytoplankton. If phytoplankton cannot photosynthesize, then they cannot create energy or food. Without phytoplankton, the rest of the marine food chain suffers.
International treaty called the Montreal Protocol to ban ozone-destroying gases such as CFCs, then found, for example, in aerosol cans and air conditioners. On September 16, 1987, the first 24 nations signed the treaty, 173 more have signed on in the years since. Fast forward 27 years. Ozone-depleting chemicals have declined, and the ozone hole appears to be on the mend. The United Nations has called the Montreal Protocol the most successful treaty in UN history. Yet despite Montreal's success, something is not quite right. A new study by NASA researchers showed that a key ozone-depleting compound named carbon tetrachloride, or CCl4, is surprisingly more abundant in the ozone layer than it should be. We are not.
And this is more to explore for future.